Hey there, Joel here, and welcome to this online class. Today we are going to learn a mathematics topic of class 7th. So let's roll that intro. Here I have a nice, delicious looking pizza which is cut into 6 pieces, and I offer it to you. So you say, okay, thank you, and you eat one piece. Now in that, the entire pizza was made or comprised of 6 pieces. Okay, the whole pizza, that's the reason I've written the word whole. Okay, made of 6 pieces, out of which you ate 1 piece. So next part I can write, if someone was supposed to eat all the 6 pieces, then the whole pizza would have got over. But he ate, or rather you ate 1 piece out of the 6 pieces, right? So, and that whole 6 upon 6 will become 1. So we are talking about a fraction. This word was originated from a Latin word which means, or rather the Latin word is fractus, and the meaning of that is broken. Okay, when we cut a piece of pizza from the whole of it and say 1/6 of the pizza piece that you ate, right? So you're not eating the entire pizza, but you are eating 1 piece out of those 6 pieces, which means you are eating the part of it, the broken part, the fraction of it. Okay, and that is what we are actually studying in this chapter, which is fractions and decimals. Now, before I even start this entire lesson, I would just recommend you, if you have forgotten your tables, then please recap them and then watch this video, because if you haven't, then you will feel that this chapter is the most difficult one. So please learn the tables at least from 2 to 9. This is the basic a 7th standard student should know. So make sure you know tables first, because the calculations will become much more simple only if you know tables. Otherwise, or chapter सारको difficult तुमका. Okay, so with that being said, let's get started with this. So this is what you have already studied. A fraction, okay, can be categorized or can be subdivided into these 3 types: proper fraction, improper fraction, and a mixed fraction. So let us take an example of each. So imagine again the pizza only. Instead of 6 pieces, I have 5 pieces, and you ate 2. So the fraction, a proper fraction, would become 2 upon 5. Also remember that when you say a fraction is proper, which means the smaller number is on top and the bigger number is down. And if you don't know what this means, then this number is called as numerator and this number is called as denominator. Okay, now numerator and denominator. When numerator is smaller and denominator is bigger, then we say it is a proper fraction. So I hope you are able to understand this. You have already studied this in the 6th standard. So how do I remember which is the numerator, which is the denominator? Simple logic. Denominator is down. They are starting with D and D, right? So denominator is down, numerator is on top. Okay, so they're just two words, right? So down means denominator, on top it's numerator, not numerator. All right. Now, same thing if you're talking about an improper fraction, all that will change is the numbers. So here my number 7, which is bigger number, is on top and smaller number is down. Let me just clear this 1 sec. Okay, so here the numerator is a bigger number and denominator is a smaller number, then it's a improper fraction. Sarke naate. Okay, because if you're going to just think of it as I had 3 pieces of pizza but I ate 7, it doesn't make sense, right? It's improper, it's illogical, I can say. So improper fraction. Okay, and the other one is a mixed fraction. So mixed fractions are written like this: 2 5/3. Okay, and not 25 or something like that. So let us just see how they need to be written. Very important. Okay, because most of the times this is not told to you all, and then you just write the way you feel it looks good, and most of you will write it the wrong way. So let us take an example here. How to write a fraction on your notebook. Okay, so whenever you're writing, please make sure that you use 2 lines to write them. Okay, sometimes students write it like this. Okay, in 1 line only, in tiny numbers. Not so good idea, because the more congested those numbers will get, the more complicated the problem will actually look like to you. It will look, it doesn't become difficult, but it looks like that. So make sure when you are writing the numbers, they are written this way. Use those 2 lines which are there, these 2 lines, use them and write the fraction. Okay, or sometimes a student write it like this. Instead of writing this way, they prefer writing 8/3. Again, this wrong symbol doesn't mean it's incorrect, but it's not so right way of writing it. Okay, the meaning of the number doesn't change, the meaning remains the same. Only thing is it looks a little difficult when you are able to solve them. Mixed fractions are written like this: 7, okay, on the line, 4/5, and not something like this. Sometimes this can look like 74/5. Okay, so make sure you are writing them correctly. And let us take the last example. Please make sure that the bar, okay, that is put as a dividing sign, make sure that this bar over here doesn't touch or go below the other number. So it has to be written this way. I hope you are clear how to write a fraction. Okay, very important, because as you go on progressing to solve a number of questions, if you don't write them properly, trust me, the entire chapter only will look difficult. And fraction itself, when you look at numbers, students will like, oh, because I know chapter about this now. Okay, so I'm trying to keep it as simple as possible. So, and the first step to make it simple is writing, neatly. If you don't write it neatly, not going to understand. All right, let's go ahead. So, find the equivalent fraction. So, let us take an example here. 1/6 multiplied by 2, okay, and divide by 2. Now, why multiplied by 2 and divide? What is the meaning of equivalent fraction? If I would put both the numbers, okay, this 1/6 on a weighing scale, okay, 1/6 of something, and then I put this value, that is 2/12 on the other side, then they are equal. Now, why do I say they are equal? You will say, so 1/6 and 2/12, kitkono equal, like this. So, what will happen is, if you remember, initially I told you need to learn the tables well. That's when they have been used. So 2 times 1 is equal to 6 times 12. So 2 1s are 2 and 2 6s are 12. That common number that I have thought of to divide is 2, right? So that's how this 1 upon 6 and this is also an equivalent fraction. So let us quickly take another example here. So what have I done? I have just tried to think of any number, and for simplicity I just took 2, and that number I have multiplied in the numerator and denominator. If I would do it only in one place, then it becomes multiplication of a whole number with a fraction. So we'll come to that point later, but right now just focus on, if you have to calculate an equivalent fraction, then you need to multiply a number in the numerator as well as in the denominator. Okay, let us take another example, 3 upon 5. So I can multiply number 4 in the numerator as well as in the denominator, and when I do that, my equivalent fraction would become 12 upon 20. How did I get 12? 3 times 4 is equal to 12, and 5 fours is 20. Let us take another example, 7 upon 2. Now to find an equivalent fraction, I need to think of a number which needs to be multiplied. Okay, so here the number that I'm multiplying is 5. So 5 in the numerator, 5 in the denominator. So when I do that, it will become 5 sevens is 35 and 2 5s is 10. So all these fractions, 1 upon 6, 2 upon 12, they are equivalent. 3 upon 5 and 12 upon 20 is equivalent. 7 upon 2 and 35 upon 10 is an equivalent fraction. So can you find out 5 equivalent fractions to 6 upon 5? You can pause the video and comment it in the comment section. What could be 5 equivalent fractions? Is it compulsory that what you think and what someone else thinks should be the same? No. I can think of any number and multiply, right? So what I'm going to do is, I'm thinking, okay, I think of a number, and so first I'm multiplying by 2. So 2 in the numerator, 2 in the denominator, which will become 12 upon 10. One equivalent. Second equivalent, think of another number. So I thought of 3. 6 3s is 18, 5 3s is 15. So once you have decided one number in your mind, keep it the same in the numerator and denominator till you get one fraction. Next could be 24 upon 20 and 30 upon 25, and last would be 36 upon 30. So what I'm doing, I'm just thinking of a number and multiplying it in the numerator as well as in the denominator. To do what? To find out equivalent fractions. And if you have understood all whatever is there on this slide, then you can practice these two and then write it in the comment section, so that practice makes the man and the women perfect. Alright, so let us take another example, a different problem actually. Ramesh solved 2/7 part of an exercise while Seema solved 4 upon 5 of it. Who solved the lesser part? Now, if you look at these numbers and straight away, if for example, if it was just as Ramesh solved 7 problems and Seema solved 5 problems, you could immediately tell who solved the least, right? If they were whole numbers. But in this case, it is a fraction. So how do we actually tell whether it is, who has solved the less one? So let us try and, picturize it first, because if you're straight away going to solve, then you might not understand it well. So always in mathematics, if you can't understand, draw. That's the way it has to be. Okay. So I have 2 sheets of papers and something is written there. I can't see what is written. Okay. So one is the answer paper of Ramesh and the other one is of Seema. Alright. Now, Ramesh solved 7 parts of the exercise. So for simplicity, what I will do is I will consider that the entire paper that is there is the entire exercise. Okay, and to say that Ramesh has solved 2 parts, I have to divide that entire exercise into 7 equal parts, just like that pizza what we were discussing about initially. One whole pizza was divided in 6 pieces, out of which you had 1. Okay, so here the entire problem is divided into 7 equal parts, out of which Ramesh has solved 2. I hope you are able to visually think this entire concept. So this would become first part and second part. So here it is done. And for Seema solved how many? 4 parts out of 5. So her quantity of the exercise, which is the same for both of them have solved the same exercise, right? But in her case, we are dividing that entire exercise into 5 equal parts, out of which 4 she has solved. Now clearly when you look at the blue side and the red side, you can tell who has solved the lesser part. But is it really possible that every problem that is given to you, you can draw pictures like this? Not possible, right? So what could be the other way around? Other way around would be getting both this fraction on the same level. Simple example. If I have this pen and this pen, and I keep them way apart to each other, and I ask you, Baba, into the hunch pen orle ha? You will not be able to tell me directly looking at it, right? Unless what you will do, you will keep them close to each other and keep them on the table. So what are you doing? I'm not keeping it like this. I'm keeping it on the same base, right? Then only I will be able to tell so same way, when you have these 2 fractions, 2 upon 7 and 4 upon 5, you have to get them on the same level. Then only you will be able to tell it easily. Now how do I do it? Because in one case the base is 7, in the other case the base is 5. So how do I get them at the same level? All I have to do is find out one number, okay, which when multiplied gets the same as the denominator. So what do I mean by this? I'm taking the denominator of one of the base and multiplying it with the other. So what I have done, I have taken 5 from the second Seema's fraction and multiplied in the numerator and denominator. So what would be the equivalent fraction for this 2 upon 7? The equivalent fraction will be 10 upon 35. Okay, I hope you're clear. Now what I'm going to do, I'm going to take the base of Ramesh's fraction, that is the denominator, which is 7, and multiply it with fraction of Seema's amount of problem solved, so 4 upon 5. So this would become multiplied by 7 upon 7, which would be 4 7 is 28 upon 35. Now 4 upon 5 and 28 upon 35, they are both what? Equivalent fractions. 2 upon 7 and 10 upon 35 are both what? Equivalent fraction. So what is happening now? It is just like taking 2 pens and getting at the same level. So same way, my denominators now are same. So when the denominators are same, all I have to do is look at the numerator. One is 10, the other one is 28. So which is smaller? 10, right? So the fraction, or Ramesh solved the lesser part of the exercise, because 10 upon 35 is smaller than 28 upon 35. I hope you are able to understand this. If you did not get it still, just rewind the video a little bit and watch it again. Simple. You just need to use 2 concepts. One is equivalent fractions, and the second part is how do I make them equal. So that's the same. So I take the base or denominator of one fraction, multiply it with the other in the numerator and denominator. Same way, I take the denominator of the other fraction and multiply it in the numerator and denominator of the other fraction. That's how I get a equal denominators. Okay, so next one, converting the improper fraction into proper fraction. So how do I do this? So here, or rather I have to say it as converting, where do you go? Okay, converting mixed fractions. Okay, now here there's one number. All I have to do, it's very simple, just be with me with this. Okay, all I have to do is take this number, multiply and then add. So it would be something like this: 2 multiplied by 3 plus 1, and as well as the same thing, so upon 2. This will give us 2 times 3 is 6 plus 1 is 7, and it would be 7 upon 2. So what have I done? I have converted a mixed fraction into an this will become improper fraction. Okay, converting mixed fractions into improper fraction. All I have to do is take the denominator, multiply it with the number at the side. The answer you will add to the numerator. So it will become 2 times 3 is 6 plus 1 is 7 upon 2. Let us take another example. 5 3 upon 4. So all I will do is 4 multiplied by 5, the answer added to the next number. So this would become 4 into 5 plus 3 upon 4, which will be 5 4 is 20. 20 plus 3 is 23 upon 4. Next one, 11 5 upon 7. Okay, so this will become 7, which is the denominator, multiplied by 11, which will give me 77 plus 5, and you will get the answer to be 82 upon 7. So I hope you are able to understand. All I will do is take the denominator, multiply with this number and then add. Okay, multiply over here and add in the other case. So that's how we convert a mixed fraction into an improper fraction. Okay, why are all these problems fractions improper? Because the numerator is greater than the denominator. And if you have understood, then all you got to do is solve a few problems and write down, or you can straight away comment the answer in the comment box. 6 9 upon 5, 7 4 upon 12 and 9 9 upon 8 is what you need to calculate. Okay, so copy these problems and the ones that are given for practice. Next part, so all we have done is added the mixed fractions in a statement. So let us try and understand what it says. Seema purchased 1 upon 2 kgs of apples, or so I can say it's a mixed fraction, and 3 upon 4 kgs of oranges. What is the total weight of the fruits purchased by her? So in any case, okay, in any kind of problem, whenever there is a mixed fraction, to even start solving it, you need to convert them into an improper fraction, otherwise you can't solve. Okay, so they are mixed, so you need to, you can say, it is all mixed in the bag, I need to separate them and write them properly. So first of all, we are going to convert that 3 1 upon 2 and 4 3 upon 4 into separated or mixed or improper fraction. So this would become, so apples, converting it will become 2 multiplied by 3 at the side plus 1 in the numerator upon 2, which will give me 7 upon 2. In the same way, I'm taking the denominator 4, multiplying with the other 4 plus 3 and then so on. So oranges, right? So 4 multiplied by 4 will become 16 plus 3 upon 4, which will become 19 upon 4. So let me just write both these numbers together. So here I've written the proper fractions here, improper fractions. And now just look at this. I need to convert these fractions into an equivalent, right? Because if I have to add them, then I need to have a proper base. This is 2 and this is 4 over here. So how do I make these numbers same? All I will do is I can just multiply any number. So here I will multiply 2 upon 2. When I do that, if I multiply 2 over here upon 2, 7 into 2 will give me 14 and 2 into 2 will give me 4. So plus, okay, this will become 19 upon 4. Now when I look at this base and this base, both of them are same, so I can write it once. Please remember this, very important. These are, the basic ideas of fractions which you need to remember, and that's because this chapter is included. That is why it is there for you, because henceforth in the 8th standard and 9th standard and 10th standard, what happens is these kind of fractions are a part of your entire problem, and then students get confused just to solve this because they don't have a proper base of how you had to, what is the logic of solving them. So understand that whenever there are two different denominators for a fraction, you can't add, okay? If there are two different base or two different denominators, you can't even subtract them, okay? That was just for fun. So you need to make the denominators same. And how do I do? All I have to do is find an equivalent, and that can be done in this method. So all I did was multiplied 2 upon 2 to keep the base same, and then once the denominator is same, I'll write the denominator once. We don't add the denominator, we just write it once under one roof, and numerator are the numbers that we add, and that's how 14 plus 19 will give me 33, whereas 4 is written once and we don't add 4. So 4 plus 4 is not 8 over there. You just write 4 once when you are adding two fractions or subtracting two fractions. Denominators have to be same, and then if they are same, then you just write them once. Kgs. Okay. So you can try solving this problem. Suman studies for 2 upon 3 hours daily. That's the regular time. Okay. She devotes 4 upon 5 hours of her time for science and maths. How much time does she devote for other subjects? So 2 upon 3 is the total time, and for maths and science is 4 upon 5. So you can write this as okay, so let me just write it over here. Total time, it will be total time of study is equal to science and maths. Okay, this is one time that is given to us, plus other subjects. Okay, so total time is 2 upon 3. So how do we convert it? You already know the method. So the answer would be 5 3s is 15, 15 plus 2 is 17 upon 3. So total time is 17 upon 3, out of which she devotes 4 upon 5, which will be calculated and written over here. Other subjects is what I have to find out. Okay, So taking this fraction on the other side, so a positive number goes on the other side of equal to, it has to be subtracted, right, from the number that is given. So 17 upon 3 minus this new fraction that is going to come will be the time that she devotes for other subjects. I hope you are clear with this. I know most of you all, when you read the entire sentence, you'll be like, oh, मुझको word problems आए नहीं. They're very simple, provided you read them carefully and then try to make sense out of it. Okay, it is not that I will read the word problem once and I am genius, and you'll remember it. Not going to happen. You need to practice. You need to read again and again and again till you get it right. Okay, and whenever you're not able to understand, try and picturize it. Simple as that. Let us go forward. So here is another example over here, a different one. Okay, what I'm doing, there is a whole number which is 3 minus 4 upon 6. I need to find out the value over here. So whenever there is a number, whole number, we all usually say that there is no denominator there, but we still have a denominator, and that denominator is 1. Okay, so now what is happening? I have 3 upon 1 as one fraction minus 4 upon 6 as the other fraction. So I will have to first make the denominator same. And how do I make them same? All I have to do is multiply a number in the numerator and denominator. So to make this 6, all I have to do is multiply 6 in the numerator, 6 in the denominator. So this will become multiplied by 6 on top, multiplied by 6 down. So when I do that, my denominators are same, so I will have to write it once, and 6 threes will be here, minus 4. Okay, now to keep it all simple and not bother so much about all this, all I have to do is, let me erase this. Take the denominator, just the way you had calculated for your mixed fraction, you use the same logic. I take the denominator, multiply it to the number that doesn't have a denominator, and write the same fraction once again as it is. So that's how you will get this to be 6 multiplied by 3, which will become 18. One second. Okay, so this will become 6 threes is 18 minus 4 upon 6. Okay, so 18 minus 4 is going to give me 14 upon 6. I hope you are able to understand what is the calculation part of it. So I have a whole number minus a fraction, and to get an answer there, all I have to do is take the denominator. I used to always tell my students as there is one number which is langda, doesn't have one leg. So to give it a support, you need to take the denominator and multiply with it. Okay, and then rest of the entire fraction will remain same, nothing changes. So 6 multiplied by 3 minus 4 upon 6, and that time the denominator goes for both the numbers. The support is given. That's how you can remember and think of it, so that you don't make mistakes. Then another problem there. 6 minus 5 upon 3. Again, 6 is the langda over there. So I need to give it support. So 3 will be multiplied with it, and then the rest of the things remain the same under one denominator. So 6 and 3 are multiplied minus 5, which will give me 13 upon 3. Same way you can take another example. 7 plus 3 upon 4. Which is the langda there? 7. Okay, and here we are adding the fraction and the number. Okay, so things remain the same. 4 will be multiplied with 7 and then 3 will be added under the same denominator, and that would become 31 upon 4. If you realize, the entire problems, all these things will work the best only if you know your tables. Otherwise, he only can help you. Okay, you can take a few problems for practice and solve these. Okay, in the second case, the fraction is written first, the number is later on. Method remains the same. Which is the langda? 23. So 4 will be multiplied with 23 and then 1 will be added under the same denominator. Your answers you can write in the comment section and on your book as well. Okay. Okay, now here I have 3 fractions. One is this one, 5 upon 4, 1 upon 2 and 3 upon 1. Now I need to calculate and find out what is the final fraction. So 2 fractions I need to subtract and that answer I need to add. All these math I have to do and find out the answer. Now to solve this problem, if you look, I told you whenever there are fractions, first thing that you have to notice is the denominators. If the denominators are same, I can write it under one denominator, add the numerators, I'm done with the problem. But if the denominators are different, you have to follow a certain method, a certain procedure, which you need to concentrate with full 100% attention right now. Okay, so what I will do, I will take all these denominators 4, 2 and 1 and write it in the rough column like this. Okay, then I will draw one bar or a plus sign, you can say, something like this. And now I need to think of a number with which I can divide this number. So here, for simplicity or to start with, I will think of number, okay, 2. Now this 2, when you multiply, I need to get the answer over here. So some number which I thought of, I have written it over here. I will write the multiple of it so that my answer is 4. Okay, so 2 2s is 4. Same way, I'll write this comma over here. 2 1s is 2. And this is already 1 over here. Again, I need to think of a number. Now this part is done, over. I need to think of another number, okay, which is, I can consider 2. And 2 times 1 is 2. And this is 1 over here, this is 1 over here. The whole idea of doing this is to get all ones in this place in the end. Okay? If that is done, then whatever you're doing is correct. Okay, so let me just show you in proper font. This would become something like this. So 2 1 1 and then 1 1 1. All the numbers which are written in green are the ones which I have calculated for, and the black ones are straight away written because there's nothing else to calculate over there. Okay, now when you are done with this, the entire procedure is only to get all numbers 1. Okay, when you're done with this, these two numbers which you have thought of will be multiplied together and will be written under one roof. I hope this is clear. Again, what are we doing? We are taking the denominators, writing it in the rough column, thinking of a number and solving it. Does it mean that these numbers over here, okay, does it mean these numbers have to be same always? Not necessary. It will all depend on the numbers that you have over here. Okay, they need not be always same. It can be 2, it can be 5, it can be 3, 7, 4, any number. 4 it won't be. So 2, 3, 5, 7, 11, 13. Okay, these are all prime numbers. If you don't know what are prime numbers, don't bother. For now, you will learn them in the course of time. Before your 10th standard, you will definitely learn what are prime numbers. But if you know, well and good. So I take those numbers, okay, which cannot be further divided or further calculated for, and then use those numbers. So finally here my answer is 4. Then what I'm going to do, that 4 I have already written under one roof. Now I will take all my fractions, all the 3, and write them in the rough column again. Okay, and the number which you had got as the answer, that 4 from here, okay, this 4 over here will be multiplied with all the fractions. Okay, here first I have written this fraction 5 upon 4, 1 upon 2 and 3 upon 1, and then 4 is multiplied to it. Okay, and once you do that, look over here, that this 4 from the denominator and this 4 in the numerator can be cancelled off. Why am I cancelling? Because there is a multiplication sign. Okay, if there was an addition or a subtraction sign, I can't solve it like that. Okay, I can't divide. And here there won't be any other sign, because this is supposed to be multiplication. That's the procedure, that's the rule. Take the fraction and the number that you got as the final, which you wrote under one roof, that needs to be multiplied. So 4 and 4 will get cancelled, and finally I will write 5 over there. I can cancel 2 ones are 2 and 2 twos are 4. This 2 multiplied by 1 will give me answer as 2, and 3 fours will become 12. So signs will remain the same and the numbers will be 5, which is from here, 2, which is from here, and 12, which is when you multiply these two numbers. I hope this is clear. And after that, once you are having all those numbers under one denominator, all I have to do is add and subtract. So 12 plus 5 is 17, minus 2 will give me 15 upon 4. That is how you solve 3 fractions that are given to you, and if you need to calculate them, that's the procedure. Let us take another example. 3 fractions, 3 upon 2, 4 upon 5 and 1 upon 1. Okay, all I will do is take the denominators and write them in the rough column. So 2, 5 and 1. Then draw that symbol or plus sign, you can think of it as. Think of a number and write it there. So do you start with a random number? If you have any multiple of 2 or 2 itself, then I will write 2 as the first number. So 2 ones are 2. I can't get 5 in the table of 2, so I'll write 5 as it is. I bring it down, and 1 I can't solve further, so I'll get 1 also in the next step. Now I need to think of another number. So here I will think of 5. Can I get 1 in table of 5? Not possible. So 1 will be written as it is. 5 ones is 5, and 1 will be written as it is. So the entire logic I told you is only to find all the numbers, not denominators, as 1, 1 and 1, and then these two numbers will be multiplied together to get a final answer. So 5 twos will become 10. This 10 will be written under one roof. Okay, then I'm going to write all the fractions in the rough column, and this 10 will be multiplied to it. Whatever cancellation is possible, you can do that. So 2 ones is 2 and 5s are 10. So 5 multiplied by this 3 will become 15 over here. 5 ones are 5 twos are. Okay, so 4 twos will become 8, which will come over here, and this I can't cancel anything, so 10 ones will become 10 and will come over here. So this will become something like this. Okay, once I'm done with this, since my denominator is just one number, adding and subtraction is possible. So 10 plus 15 is going to give me 25, and 25 minus 8 is going to give me 17 upon 10. I hope you are very clear in solving this problem, because you definitely require them in your higher classes. Please learn them. Watch the video again if you are still not able to understand, and practice them. Okay. With that being said, I will conclude this video. Otherwise, this is going to be too much to take in when you're learning this chapter. So I hope you did like this video and enjoyed this entire topic. If you did enjoy, or if you did like this video, and if you have understood, then please don't forget to hit that like button. The like button is right below here. Please press it and tell me what you feel about this chapter. If I had to improve something, if something that you did not understand, please feel free to write whatever your hearts tell you as you watched this video. If you found this chapter difficult, if you found this chapter easy, please mention it in the comment section. And if you haven't subscribed, the subscribe button is down there. Okay, subscribe to this channel, and till then, take care. Please solve all those problems, and God bless you. Bye bye.